Welcome. Today we'll solve this complex integral step by step. First, let's look at what's under the square root. We can rearrange 3 plus 2x minus x squared to negative quantity x squared minus 2x minus 3. Now let's complete the square for the x squared minus 2x terms. We take half of the coefficient of x, which is negative 1, square it, which gives us 1, and add and subtract 1 to maintain equality. Substituting this back into our expression. Negative x squared minus 2x minus 3 becomes negative quantity x minus 1 squared minus 1 minus 3, which simplifies to negative x minus 1 squared plus 4. Therefore, our integral becomes the integral of dx over the square root of 4 minus quantity x minus 1 squared. This is a standard form that we recognize. It's similar to the arcsine integral. The integral of dx over the square root of a squared minus x squared equals arcsine of x over a plus c. To use this formula, we need to make a substitution. Let u equal x minus 1. So do equals dx. Our integral becomes the integral of do over the square root of 4 minus u squared. Now, we can directly apply our formula with equals 2. This gives us arcsine of u over 2 plus c. Substituting back u equals x minus 1, our final answer is arcsine of quantity x minus 1 over 2 plus c. Let's verify this is correct by looking at the domain. Since we're taking the square root of 4 minus u squared, u must be between negative 2 and positive 2. Therefore, x must be between negative 1 and 3, which matches the domain of our original integral, where the expression under the square root must be positive.